is not my topic. I don't teach it, but like there was a miscommunication. I heard that Jashil will be here.
जय कहाँ है बड़े मुझसे देखे नहीं।
नहीं 2 वीक से वो उसने कुछ मतलब 2 वीक का उसका प्लान था। तो last weekend and this weekend he was not here. So I'm hoping that he'll be here, but I ran out of things to teach, so I have to teach this now. So
No problem.
Yes.
We will support you.
yes, thank you. So well, happy
Happy
birthday day.
अभी नहीं
अभी टाइम नहीं?
नहीं बस
चलो,
हो
कोई बात नहीं,
गया
अब
तो
Okay, so we'll do binary. We'll do trees. So and there's generally the questions that are asked is binary search tree or binary tree. So you have to ask your interviewer first if it is a binary search tree or a binary tree. So a binary search tree has a property. A binary tree is a tree in which there's a node and it has a left child and a right child. And every node has a left child. I mean, every node can have a left child and can have a right child. And it can have a data or whatever. That is called a binary tree. A binary search tree is a tree in which every left node is actually smaller than the parent node, and every right one is actually bigger than the root node. So something like that. I will actually draw this structure. So in your interview, if people ask you about a question about tree, first ask them, is it a binary? If they ask you it's a binary tree, they will say tree. Ask them, is it a binary tree? They'll say yes. Tell them, is it a binary search tree? Because binary search tree has different properties. They might change the question based on that. So right now we will just write a class for a binary search tree. We will go into the binary tree questions and we can change the class and all these other things. So today is just the basic, and then I have a list of questions that we'll be reading. Okay, so if you think about a binary tree, first thing that we have to do is we have to actually figure out how this tree is constructed. And when a tree is constructed, it has data. So we will write the structure of a node. So struct a tree node, and it has integer data, which is, I'm taking integer right now, we can change it to whatever. And then it has a left child and a right child, and left child is also the same node. So we'll say a tree node star left, tree node star right. Okay, this is pretty simple. People understand this, and I think everybody over here knows what this is. So I will now start writing the class for this list, and then we will start adding. So we'll write constructor, destructor, we'll delete node, we'll insert something in the node, then we'll do the, okay. Another thing is, so the traversal can be done of a tree, right? So whenever the traversal is done, the left child, so there are 3 kinds of traversal: in order, pre-order, post-order. Left child, right child, left child, right child, left child, right child. Always the left child will come first, and then the right child will come. Root will come first in the pre-order. So this one is pre-order. Root, if it is in the middle, is called in order, and if the root is in the last, it is called post. Okay. Inherently, most of the things that are solved about a tree is actually recursive. So we'll try to do all the recursive functions, and when Jashil teaches, he will actually teach the difficult questions and he will do iterative or whatever.
Yeah, iterative he can, these people can do also
Sure.
here, so no problem. Yeah, these are the expert people. Yeah,
Sure, that's,
You are not.
yeah,
This is
and
the
that
normal
is,
tendency, all
and
the-
that is the thing, like, if you have to come on board,
Yeah.
so in interview too. So if you can explain that, that's very good, and we should encourage doing that. Okay.
In high school time, all the brilliant students used to sit in the back. You know this, right?
Yes.
I used to sit in the back. I was not the brilliant. I was.
By the way, yes, I'm also not brilliant, as I told you.
Every brilliant says like this. I'm not the brilliant guy.
Not the brilliant.
No.
People don't.
No, and this is on the record. This is on the record. I was actually not brilliant. Like, I was actually an SDET at Microsoft, and I got fired from Microsoft because I had fights with my manager and whatever reasons. No. So I was actually fired from Microsoft, and I knew that I actually know coding. I know how to do these things, but when I was starting to prepare after I got fired, it was actually very difficult. 1 month, like I had to wait for 1 month, and then I was like, okay. So I was thinking going back to India, this and that. So I was very. Then I realized, like, everybody, I'm going through this. I'm not writing trees at Microsoft every single day. I'm not writing linked list every single day, but in interviews they are asking these questions, and I was thinking, like, if I'm facing this problem, other people are also facing this problem.
Exactly.
And the thing is, like, I was facing that problem for a long time, like 2 years straight, 2 to 3 years that I had problem with that manager, and every day I used to think, you know what, I will go and I'll read trees and I will go and give interview in a different group. I never did that. So
why
if you
have a
are-
problem with manager? Because of these questions?
no,
I mean,
It's
project
just-
related something.
it was more of a, I think it was more of a personality clash. And she had to play her politics, and I didn't listen to her, and I think I have a problem, like I fight a lot, so yeah. But anyways, regardless. So yes, I'm not brilliant.
हम लोग आपके वक्त हैं, हमसे
नहीं।
बात मत करना। एक आध घूसा पड़ा तो बच भी जाएंगे।
A binary tree.
कौन?
Okay. So you write public and private. Okay. And struct a tree node which had an integer data and a tree node.
Again, you are defining the structure.
I'm defining the entire class.
Okay.
So I'll write the whole thing. Start, right. Okay, and we need to have a root node. So we will define a tree node star root. Okay, so that's the root, and we will define the constructor and destructor. A binary tree to the a binary tree, and delete tree. Delete tree will call actually. Destructor will call delete tree. Delete tree will delete the entire tree. Or maybe I just don't need. I'll just write a delete node. A tree node star node. I actually never write in the public. I actually never write.
Yeah, delete should be the
Pointer.
internal function.
Yeah. So whenever I write C++, I actually never write a pointer in the public.
Why?
Because most of the times, like, there's memory leaks and stuff, so I write it in the private section, and I feel that, like, if I write this, if some other person is using my library, then they don't have to deal with pointers. I try to do the pointer part on my side, and then I give it to them.
So, Ashish, I have a little over here.
Sure.
Related to the C++ concept. If we put destructor in the private, will it work or not?
No, destructor should be
Always private, public.
Destructor should be public, because you have to delete it. So if I actually don't, I have never done that. I think, yeah, destructor has to be public.
Yeah.
Mhm. Otherwise, there's a default destructor which is being called. I should actually do that right now. I will do it. Okay. Then we will delete a node. Then we will do a void insert. We need to insert something in that table. Right. Insert, and then we'll do void print pre-order. Let's do pre-order print in order and blah blah blah, and then we'll go with the different functions that we will implement. Okay, so you understood the concept of a node. A tree node is a node like this, which has a data, and it has two pointers. One is pointing to the left side, one is pointing to the right side. So that is the structure. There's a left and a right. There's a root, and we are writing. This is a binary search tree. We can change it to a binary tree. We'll go into that later. Okay. So a binary tree colon a binary tree. Okay, and then the constructor will. I just don't need to do anything. I'll just say root is equal to null. Okay, a binary tree colon destructor a binary tree. It will call delete node root. Okay. So it just calls the root, and root will delete everything. Let's write the delete node. Delete node a tree node. So in this, what we will do is we will actually figure out if the node exists, then we have to do something, otherwise we don't have to do anything, right? So if the node exists, what I will do is for me to delete, let's say there's a tree like this, and we are doing it recursively, right? So root comes over here, root says I want to delete myself. So if I have to delete myself, I cannot just delete myself because like there are, my children are also there. So the children have to go away, and then only I can delete myself. So what I will do is I will recursively call delete my left node and delete my right, then I will call delete my right node, and then I will delete myself, right? So for this to actually go away, this has to go away. For this to go away, this has to go away. For this to go away, this has to go away. Now when we reach over here, this does not have a right and a left, so then we can delete this. So this will be calling this function recursively over and over again. So we will call delete node arrow left, and delete node arrow right, and then delete node, and I think, and then I just write this node is equal to null. I don't have to write this, but like before Microsoft, I used to work in a company that had BIOS operating system. So in that, like C++, even after the delete, it did not make it null. So I had to do that for everything. So that's a bad habit, or I don't know.
After deletion,
after deletion, I also make it null.
आशीष इसमें ब्रेक कंडीशन कहाँ पर?
ब्रेक किसके लिए? If node exists.
नहीं, if node exists में तो ब्रेक नहीं होगा. देखिए आप
क्यों?
पहला वाला रूट आप
हाँ ठीक है. पहला 1 2 3 4 कर देते हैं. 1 2 3 4 5 6 7 8 7 इतने करते हैं.
हाँ करते.
We'll say root comes 1. 1 calls 1.
1 calls 2.
1 calls 2. 2 calls 4. Now 4 comes in here, 4 exists, right? Delete node, 4's left, there's nothing. So it comes, 4's left is nothing, it will go away. Then it will come to this one. It will say delete node, 4's right. 4's right is nothing, it will go away. Then it will come to this line. So it will say delete 4. So now 4 gets deleted and then 2 is left.
I get the point.
So 2, yeah, so that is how it works. Okay. Yes, my mind also does not work recursively, but most of them. And if you think about it, like if you think about it, most of the things in the world actually are a tree kind of a structure. If you see the leaf, if you see a leaf and see like how the veins and stuff like that goes away, it's a tree kind of a structure.
Right.
If you look at our lungs, it's a tree kind of structure. If you look at the rivers,
Here.
here's a
Hairs
river.
are not.
If you look at the river,
Lot of branches.
yes, but if you look at rivers also do the same thing.
Yeah.
So most,
One root, lot of branches.
so most of, I don't know, but I think this is a very efficient structure. That's why inherently Mother Nature or things do it like that. Okay, so we have deleted a node. We will do an insert now. There is a different question saying that, let's say 4 is there. Let's say if I have to delete 3, that is the question that you guys were doing, right? You and Sapna and everybody. So when you delete the 3, then which one gets to? I am not doing that right now. We'll do that later.
Reordering, tree reordering.
Huh?
You have to reorder the tree after deleting.
Yes. So she will do it, right? Yes.
Prashant will do it.
Insert.